how many liters of one do you need to add to the other to make a different solution that has a third amount percent acid. So in order to do that, you're not going to be able to do this, cut the number in half and add some and subtract. So you're not going to be able to do that. But you will be able to set up some equations of things you know, and then you'll be able to piece them together to get some answers. All right?
It'd be
So that's what we're
doing the percent times the variable plus the other.
Yeah, we're not going to get into that. I just gave you a brief example, but there are actual problems where we can do that. I mean, I could do that in next I can do that tomorrow. I can give you one of those solution problems if you'd like. They're difficult, but it could be fun.
Do you expect the test on Friday?
I'm sorry?
Should we expect the test on Friday?
That's a good estimate, I would say, but we don't know. Last session, solve systems of equations algebraically. And I'm going to move this up. Solving systems of equations algebraically, I already gave it away. So what you're going to see today is more systems problems that they want you to solve algebraically.
Yay.
So now we're doing what we did yesterday, except you can drop the graph for now. On your test, you'll have to know how to graph. But now we can just focus on where we left off yesterday and get even more practice with systems of equations.
Wait, is
solving we're going to be using this as a great tool. It's a tremendous tool for solving problems with multiple constraints in the real world. All right, questions before we move on? No? All right.
Actually, so solving algebraically is when you subtract the equations?
Or substitute.
Or substitute. Okay, thank you.
Okay, so the first way they're saying one method is called substitution. We already know about that. Wow. Really? Okay, take 15 seconds. Go.
Wait, what does that say? I can't read it.
We'll make it bigger.
Oh
my God.
That's.
How do you do this?
None.
I'm so confused.
It's already halfway solved. For y, the y part is already half your solution.
So I guess they just want you to substitute.
Real simple subtraction.
I don't know. It can't be 3.
Oh my gosh.
So I rewrite the first equation with parentheses for the y, and I substitute the y. Then I subtract 2. And 3 is equal to x.
Oh my gosh.
So you can put...
Really?
What's the coordinate then?
It'll be 3, 5.
3, 5.
Yeah. This is a clean way to put it in your answer key. I can grade it so fast when you put it like that. Then I know your solution is that coordinate. What is that location? What's special about that location?
That's where the
It's always positive.
That's where they.
No.
the lines intersect at that point.
That's where the lines intersect, yes.
Yeah.
By the way, what's the slope of this line here?
1.
5 over 1.
Nope.
No, just 1 over 1.
Nope.
5 over 1.
Nope.
1.
Nope.
No slope.
I know there is.
Nope.
Wait there.
Wow. You might want to graph it. What is the graph of the equation y equals 5?
It's a straight line. It's a vertical. No, it's a horizontal line. So it has no slope.
It's undefined.
It does have a slope. No, you're wrong.
It has
0.
0.
Ah, there we go. Slope is 0. Remember that. Look, everybody. Positive slope, negative slope. What's in between doing this and doing that? What's in between?
0.
Flat. This is not in between, is it? If I'm getting more positive, this would not be in between. As I'm getting less positive, I'm getting flatter and flatter and flatter, you would go to 0. Then once you go below 0, you are dipping down. Then you're going negative, 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 negative. Okay, so 0 is flat. Straight up and down vertical is undefined because you could argue that it's infinitely positive. Okay, or if you go down forever, keep increasing the decreasing, and you go straight up and down, then it's negative infinity. So you don't know which it is. A vertical line could be both, so you can't define it. So it's the vertical one. X equals 5 would be a no slope, undefined slope. Okay.
Mr. Rosenthal, you can think of it like angles, pretty much like an angle.
Yeah, 0 degree angle, yeah, would be like that. Then you open up the angle, but then you have 90 degree angle would be undefined, right?
Mm-hmm.
All right, next one. Solve the system of equations algebraically. Here we go, a little bit more challenging now.
Okay.
Go ahead and take a minute or so for this, go. This one I'm going to do elimination. You can solve for y by adding 3x over there. That's one way to do it.
Mr. Rosenthal,
Mm-hmm.
when you're simplifying the 5y, how do you know how to do it? How would you do that?
I don't know what you mean by simplifying the 5y. What does that mean to simplify the 5y?
Put these into standard form before you solve them.
This is in standard form. Both of them are in standard form. See, the variables are on the left together. Here, the variables are on the left together.
Oh.
Now, one thing I might do to change this around is actually switch places here.
Yeah.
Right onto my paper. Put the -3, make sure it's not 3x minus y. You can't just switch those. It's -3x, positive y. Now the x's are lined up, the y's are lined up. Now you don't need to do that if you're going to use substitution, but I'm not. I'm going to use elimination. Now, I can get these both to be a 12 and a -12. I can multiply everything here by 4, and I can multiply everything here by 3. And then these would both be 12 and -12. And then I can add them. But I think I can make that, it's easier just to mess with one of them. I can make that -5, so that when I add it to that, I eliminate the y's.
Mr. Rosenthal, are you adding those two
I'm going to.
systems together?
I'm going to.
Okay, thanks.
All right, so what I'm going to do is I'm going to multiply line 1. We'll call this line 1, line 2. I'm going to multiply line 1 by -5. I know it's kind of small to see, but I'm multiplying by -5 to get this next line here. So that would give me -5 times -3 is positive 15x. And that would be minus 5y, because -5 times y is -5y. And then -5 times 13 is positive 65. Okay, now add.
Mr. Rosenthal,
And 4x and 15x is 19x. The y's are eliminated. This becomes 76. I'm guessing that goes, yeah, it goes in 4 times. It's 4. Plug it back in. Whatever equation you want. It could be this one, that one. How about right here? If x is 4, -3 times 4 is -12. Then I would add 12 to the -13. What's -13 plus 12? -1. So my answer is that.
Mr. Rosenthal,
Mm-hmm.
where did you get the 15 from?
I multiplied everything in my first line by -5.
Oh, by -5.
What allows me to do that is the multiplication property of equality says that if I multiply by -5 on one side, that's okay as long as I multiply by -5 on the other side. That's the multiplication property of equality.
Why did you do that though?
Mr. Rosenthal?
Okay, why did I do that? Okay, well, if you look here, by me multiplying that by -5, it gave me -5y. So then when I add that to +5y, it neutralizes it so that there's no more y when you get to the next line. Then I add everything else.
Okay.
I got 19x equals 76. There's no more y in my equation. I can just solve for x. I can focus on just x by doing that. I'm also going to perform substitution on the same one. I'll get the same 4, -1 solution. But any questions about elimination?
I don't understand how you got from 3x plus y equals -13 to 4x plus 5y equals 11.
No.
I didn't. There were 2 separate equations.
Oh, okay. That
I
makes
color
sense.
coded it. So pink came from the other pink though. By multiplying everything by
I understand
-5.
that.
Mhm.
So
Then I used this pink, the new one, with the original purple one, and I added them.
it's like you're using a scale factor.
Yeah, scale factor of
Add, like,
I
-5.
don't understand how they're related
Yeah,
though.
two problems,
Each
then that's
equation
like
It's not that they're related. They're 2 separate lines that are not related. They're only related at the point where they intersect, which is called the solution. And at that point, they share the same XY coordinate. Therefore,
Okay.
at that special point, that special location, this X and that X happen to be the same X. And that Y and that Y happen to be the same Y, just at that one location. So when I assume mathematically that that X is that X and that Y is that Y, now they're related. And when I solve for that, I'm finding where that is, where that one point in common that they have is.
oh.
What?
Sort of.
Huh?
Okay, well, you have a purple line. I'll try to estimate what that would look like. It would be -4/5. It would be a flat. It would start up at 11. So it would look something like this. Okay, there's the purple one. The pink one would be starting way down here at -13 and would have a steep slope like that. So that's kind of a sketch of what those look like. Well, this has an XY coordinate right there, but that X is not going to be the same as some other point on the purple one here. That will have its own X. Call that X1, Y1. Call this some other coordinate, X2, Y2. That X is not the same as that X. So you couldn't treat that X and that X as the same. But there is one point where the X and Y's are the same. Where's that? Here. At that one point, and only at that point, the X for one of them is the same as the X for the other one, and Y the same. So at that XY, the X is in both of these lines, and the Y in both of the lines exist in the same place at the same time there. Algebraically, when I understand that this X and that X are the same, then they are like terms now. This X and that X wouldn't be like terms. You couldn't use them as the same variable, right? If it's unknown, an X1 and an X2 are not like terms. But once we know that this X and that X are the same when the 2 lines intersect, then they are like terms. What can we do with like terms? We can add them, which is what I'm doing. When I add opposites, I can get rid of the Y, giving me just X. So X ended up being 4 at that location. So here. Oh, by the way, these lines didn't meet over there. Where did they meet? They met somewhere here for some reason. Oh, I know why. No, that's weird. How could that have been? I sketched that wrong. My eraser.
What?
How could four negative 1 is here? How could they have met in quadrant 4? I must have sketched something wrong. But anyway, the point of it, no pun intended. The point of it is the reason we can put the two equations together. The question was, how are the equations related? They're only related at that point. Otherwise, all the other points on purple are separate from all the points, the X's and Y combos on pink. Only at that one point are they the same. So when I make them the same, I must be talking about at that point only. So that when I get an X and a Y, I know that it can only be the X and Y at that point, which is the solution to the system. Okay.
So basically, if you add and subtract the two equations with y and x coordinates, and the x and y coordinates are the same, then you can get them.
This is
This slope should have been negative. That's what happened.
Oh.
Yeah, you have to put in slope intercept.
Yeah, when I sketched it with a positive slope. So it would have been it would have looked more like this. Let me make it a little bit more accurate for you. So the pink one would have been a positive 3x, and it would have started down here, and it would have come up like that, something like that. Okay, and the purple one would have started at 11 over 5, 2.2. So it would have started here, and then the slope would have been negative 4/5. So it would have been flat. Okay, but there's your 4, negative 1 right there. That's where they met.
Yeah.
Okay.
Mr. Rosenthal?
Mm-hmm.
I have two questions. How did you get negative 1 for the y?
Good question. I plugged the x of 4 back into pink. Tell me, what is negative 3 times 4?
Negative 12.
How would you neutralize a negative 12? Zero it out. How would you get a 0 pair?
You add 12.
Okay, that would get rid of it, and then you must, with the addition property of equality, if you add to one side, you better add that 12 over here. What's negative 13 plus 12?
1.
Negative 1. Yep.
Also, when can the x-axis, like if you had negative 5 for your x and negative 4 for your y, how does the x for your slope, that was your slope, how does the x-axis move negatively?
By going to the left.
Oh, okay.
Along the x-axis, yes. How does a slope negative? Look at the purple one. It goes down and over instead of up and over. From left to right.
So for the x-axis to move negatively, it would have to go to the left?
The x-axis doesn't move, so the way you're wording that is a little bit inaccurate. I want you to understand what you're saying.
I don't mean that. Yeah.
So to be negatively sloping, your ratio, which is your slope of delta y over delta x, one of them has to be negative and the other has to be positive.
Oh, okay.
Right? So either a negative over a positive or a positive over a negative will yield a negative slope.
Okay.
If delta y and delta x have the same sign, then it's a positive slope because a positive over a positive is a positive and a negative over a negative is a positive.
Okay.
So that means on this pink one, I can go up and to the right, or I can go down and to the left. Negative is still along the positively sloping line. With the purple one, I can go down and to the right. See how down is negative, to the right is positive?
Yeah.
Or I can go up, which is positive, and to the left, which is negative. So the signs of your change have to be different to get a negative slope.
Okay.
Great questions. Anybody else?
Yes. You might have already answered this, but I'm just going to ask, why are you multiplying?
Where?
It looks like you're multiplying because you're obviously not adding adding stuff.
Are you talking about from this pink line to this pink line?
Yeah.
Well, what was I able to do once this was the opposite, when these were opposites and I added them? What was I able to do? Do you see any y down here in black?
No.
Oh, no. What happened to the y's?
Got canceled.
That was on purpose. It wasn't an accident.
I don't understand. Where would you get?
How did I get that to be -5 when there wasn't anything there before? It was a 1.
Because you multiplied by -5.
Okay, so that explains why I multiplied. I multiplied to get this result, this
So
opposite.
you can eliminate it.
So that I could eliminate it, right?
Wait, so you're saying, where did you get 15x though?
Okay. The multiplication property of equality says that if I multiply one side by -5, I must multiply the other side by -5. So if I multiply the -13 by -5, that explains the +65.
But what about the 11?
Hold on 1 second. The 11's part of purple. Purple didn't come from pink. It was already there. It was given. Separate equation. I'm only changing one equation. If I manipulate one equation, that has nothing to do with the other equation. The property of equality is with one equation at a time. Multiplying by 5 with one equation doesn't have anything to do with me doing anything with the other equation. Purple is left alone for right now. So just focus on pink. As I multiply the right-hand side by -5, I get 65. I then must go to the left-hand side and multiply by -5. That explains the -5 here, but it explains also how I get a +15 here. I multiplied the right side by -5, and so I must multiply the left side by -5. That's just the multiplication property of equality. Does that make sense?
Yeah.
Everett, does that make sense?
Sort of. So you chose 5.
No. If I have 10 equals 10, and I multiply that by -5, I get -50 equals 10. That's not right.
No.
Why not? Because when something is in balance and you change something on one side, you must change it the same way on the other side. So you multiply them both by the same amount. What I did is I multiplied that by -5. That means in order to remain equal, you must also multiply the left-hand side by -5. Now, the left-hand side is made of 2 parts, but that's not a problem. When you multiply something that's made of 2 parts, you distribute. So you multiply them both by -5.
Okay.
-5 times y is -5y. -5 times -3 is +15. I did not touch the purple equation. I could mess with the purple equation. I actually opened up by saying, in the beginning, I could have gotten the -3 and the 4 to both become 12 and -12. That would mean I can change the pink equation and the purple equation so that they match up as opposites. So I could do that. But why do that when I can just make one move? Why take 2 moves if I can do it in one? Sometimes you have to do it in 2 moves when you do elimination. All right, let me go back to, now it's important that we're taking our time so that you guys can soak this in. So don't worry that we're not going forward. We're going deeper. How would I do this with substitution? Well, you might like this way. With the pink equation, I'll add 3x to both sides. Now I have this, +3x minus 13. Now it's solved for a variable. Now what I'll do is I'll rewrite the purple equation, and I will remove the y, and in its place,
3x minus 13.
y, which was right here, if you look, and I remove that, I'm going to put y is 3x minus 13 because that y and that y are the same at that point, right?
Yeah.
Because they're the same only at that point, which is the point I'm trying to find. That's what I'm trying to find. So that's why we're doing that. Now, distribute. Here and here. 4x plus 15x minus 65. Interesting, those same numbers are emerging.
Yeah.
19x, add 65 to both sides to get 76. Divide by 19 to get x is 4. Plug it in the same way to get y is -1. That's substitution. Probably around the same amount of steps and lines. A lot of students early on prefer substitution. You have more experience with that, so you're more comfortable with it. I much rather enjoy elimination. It's like a fun new puzzle. As long as you understand how to do it. Don't be intimidated by it, practice it. Like the Rubik's Cube, you can start to learn it. It's intimidating at first, and then you start to learn it. Anything's like that. Piano, an instrument, riding a bike.
I learned the Rubik's Cube.
How impossible was learning to ride a bike at the very, very first instance you got on a bike? You know, and you can't think, oh, I really don't want to ride it because it's too hard. No, you keep trying and you get it. So try elimination, know how to do both ways. Okay, any questions about the solution for -1? Okay, I better move this up now, else I might get yelled at. See how I'm kidding with you guys?
Yeah.
All right, who's recording this, by the way? Who's me? Who? Ethan? Okay, you're going to share that with me somehow? Okay, everybody try that one. Use whatever method you like. I recommend you try something new. Well, I'm not going to write it this way, actually. I'm going to write it with the 4x and the y. Why am I allowed to switch that?
Because of the commutative property.
No, that's switching the order of multiplication or addition. This switching the sides, what's on the balance scale, you're switching, if I have 5 plus 5 equals 10, that's the same as 10 equals 5 plus 5. If I put a 10-pound weight and then 2 5-pound weights, it will balance no matter what side I put them on. That is called, does anybody remember? It's a property, but you don't get it till geometry, but I did mention it.
Wait, what?
What's the property that says this? If A equals B, then B equals A. What's that property?
Identity?
No.
It's the
From geometry, it's not in our curriculum.
I know this.
Zero
it's
property? Property
No,
of
it's the-
equality?
No, it's the
Property.
Symmetric property.
Symmetric property.
It was there with symmetry. And then,
Of equality. It's something that's true about equality. Because if A is great, what if A is great?
oh my god.
Is B greater than A?
Is it?
No.
They're equal.
No.
So it's not something that's true of everything. It's true of equations of equality. So because of the symmetric property of equality, I'm just going to go ahead and switch it right onto my paper. And this lends itself to elimination. You can make that a 4 or a -4, or I like this, make that a +3. That's even easier.
Yeah, that's what I.
Now, you can't just make it a +3. You must account for that. That's what the manipulation's all about. So I'm going to take line 2. Here's line 1. Here's line 2. I'm going to take line 2. What would I multiply it by on both sides?
+3. Yeah, +3.
3 times line 2. That will give me 12x plus 3y. Now I'm going to take line 1 and add it to line 3. It'll give me 14x. The y's are
Yeah, I
gone.
got the answer.
Negative 1/2. Now I'm going to plug it back in. Negative half of 2. Well, half of 2 is 1. Negative half of 2 is negative 1. Okay? Minus the 3y equals negative 10. I'm going to add the 1 to neutralize. Negative 3y is equal to negative 9.
Not myself.
Y is equal to positive 3. Solution is negative 1/2, positive 3. So I like the elimination. I mean,
I
you
get
could
the negative 1/2. I understand the positive 3, but not negative 1/2.
When you divide by 14 on both sides, negative 7 divided by 14 is negative 1/2.
You see that? You see it or no?
I do.
Okay. Questions?
Like when you divide, it's just basically like a fraction. So like negative 7/14 simplified is negative 1/2.
To find 12x plus 3y equals 3, did you multiply everything on line 2 in the blue?
Yes. By
the one
3.
above.
Yep.
That one by 3.
Yes, sir.
Mr.
And
Rose,
then
Let Charlie finish real quick,
sorry.
please.
and then what did you do? Did you
Then I added it to line 1 because I saw that the 3y and the negative 3y would cancel out.
where'd you get the 7 from though? Oh, because
Negative 10 plus 3 is negative 7.
what happens to the second line?
Nothing. I don't use it anymore. I transformed it into the third one so that I could use that with the first one.
Okay.
I mean, you can always use it later to plug back in your x solution.
And then to find y, you just plugged in the x.
That's right.
Okay.
Probably would have been even easier if I plugged it into the second one. Negative half of 4 is negative 2. Add 2 to 1 to get the 3. That's even easier. Okay, you guys want another? Let's see if there's another one. There is. Okay, good. Ooh, look at this one. Okay, this one you might have to change both if you're going to do elimination. Oh, Everett, did you have a question from the last one?
What'd you multiply for the last one?
I multiplied by 3 on both sides. I'm sorry, I erased. I should have waited. I forgot that you also were waiting for a question. Just try this one, and I'll make sure that we stop for a second at the end to see if you have any questions about it.
Would you wait? Can I ask you a question right now?
About this one?
Yeah.
Yeah, go ahead.
Would you multiply by 4y for this one? I'm 24.
Well, first of all, tell me what variable are you going to go to eliminate?
I'm gonna eliminate the y.
You're going to eliminate the y's. So
Yeah.
what number can you make both of these that would be opposites?
20.
20. So you would have to multiply this whole line by 5, and you'd have to multiply this line by 4.
Why do you multiply the top line by 5 and the bottom line by 4? I don't understand.
Because if you multiply this by 4, you're not going to get 20. You're going to get 16.
Oh, 4
It's like getting a common denominator.
Hey, Mr. Rosenthal, wouldn't you have to multiply like either the second line by like by a negative in order to get like a positive 20.
Now remember, if you don't have to, you can subtract the 2. You can use the subtraction property.
Oh yeah.
But if you want to add, if you love adding and you don't want to do it as subtraction, then you might want to multiply by a negative to do that, which is what I'm going to do. I like doing that the way you're saying.
Yeah.
Okay, so I'm going to take line 1 and I'm going to multiply it by, let's multiply it by, I'm going to multiply by negative 5. So here we go, everybody. Negative 5 is times 2x is negative 10x. Negative 5 times negative 4 is positive 20y. Negative 5 times 6 is negative 30. Now I'm going to take line 2. I'm going to multiply that by just 4. I'm going to get 12x. Negative 5 times 4 is negative 20y. Those are going to be opposites now. And this is going to be 12. And here we go. Let's get into it. Now we're going to add line 3 and 4. Line 3 plus line 4. Okay. 12x plus negative 10x is just 2x. Y's are eliminated. This becomes negative 18. See, this method is, it's kind of nice. And then x is negative 9. Pick an equation of your choice out of the 4 to plug in the negative 9, whichever one seems easiest to you.
This is so easy.
Good.
I understand. All you have to know is just what to eliminate, right?
And it's your choice. You get to choose what you're going to try to eliminate. And it's kind of like a game. You're manipulating it so that you can do it your way. So you can get your way.
Mr. Rosenthal?
Mm-hmm.
If it was, where'd you get the minus sign in line 2 from? Not that one.
Line 1 and 2 are given. Those are the given equations.
The one with the 4 in front of it. The 4.
Line 4.
Yes, that one.
Okay, where did I get 4?
No, where did you get the minus in front of the 20, the negative in front of the
It was already minus up here.
But that was minus up there, and that's plus.
This is minus, that's minus.
But that was on line 1, that was minus, and now it's plus on line.
Because here I multiplied by negative 5, not by 5.
Oh, I messed it up.
See, in the beginning of the problem, it was minus and minus.
I multiplied by negative 4 instead of just regular 4.
If I multiplied by positive 5, I would have gotten negative 20 and negative 20. And when you add them, you would get negative 40.
Yeah.
Now you could have them negative 20 and negative 20, and you could subtract them because anything minus itself is 0. But then you would have to do negative 10 minus, right? Or you'd have to do 10 minus 12. You'd have to do negative 20 minus negative 20. And then you would do 30 minus 12. Okay? And you'd still get the same answer. So you can do it by subtraction. But if you like adding the 2 equations instead of subtracting them, then you're going to want these to be opposites, not the same. In the beginning, they were the same. See that? So by multiplying one of them by a negative and the other by a positive, I got the signs to be different so that I could add them. Okay, so let's finish this up. Let's plug in the negative 9 here. 2 times negative 9 is negative 18. How do I neutralize the negative 18?
Add 18.
Add 18 to both sides. So now I have 24. So now I have negative 4y equals 24. So divide by negative 4. Y is equal to negative 6. So my solution is 9, negative 6.
Negative 9.
Negative 9. Negative 9.
Negative 9.
Yeah.
To find y, you
I plugged in the x I got into any one of these. I happen to plug it into the first one. But if you plug it into the second one, guess what you're going to get? Negative 6. If you plug it into the third one, you're going to get negative 6. If you plug it into the fourth one, you're going to get negative 6. Pick any of the equations because they're all true.
So you put it in, and then it would be negative 18 minus 4y equals 6.
Then neutralize the negative 18 by adding it, which would make that 24. And it would be 0 here. And then you have this.
And then
It's
you
just a way to check your work.
and then
You can plug it back in, everything. You can plug the X and the Y in and see if it's true to check your work. Yeah.
okay.
Any other questions, Everett? Anybody?
Yes, I have a question.
Okay.
So, do you plug in the X, which was -9, for the top 1 and 2, or the bottom 1 and 2?
Any one you want. It will all come out to -6 no matter which one you choose.
So, I got negative 18 minus 4y equals 6. And
Correct. Then you added 18 to neutralize the negative 18, right?
Wait a second.
You said negative 18, right?
Yeah,
So how do you neutralize a negative 18?
add positive 18.
You add 18. So then you have to add 18 to the 6, which gives you the 24 down here.
And then the 24. Okay, wait.
Now you've gotten rid of the negative 18. You said the rest of it was minus 4y, right? So if you look down here, I have minus 4y or negative 4y equals to 24.
So wait, negative 18 plus 18, and negative 6 plus 18. And 6 plus 18,
Correct.
which is
24.
4y equals.
No, it's not. No, it's not 4y. It was minus 4y, so it's negative 4y.
Minus 4y equals 24.
Look here, Everett. Negative 4y equals 24.
And then you just do division. And then
Yeah.
That's it.
I sort of understood that. That's great.
Excellent.
Mr. Rosenthal, didn't you say that you can't have 2 negative? Or is that the slope, or is that just?
There's no, I'm not expressing slope here.
Yeah.
I left these in standard form. If I want to solve for y, then you can get the slope that way.
Okay.
All right. Any other questions? All right. If you solve a system of equations and the result is false or a false statement, the system has no solutions. We already talked about that. If the result is and when would that happen? When is there no solution? When the two lines are what?
Hello.
Parallel. They never touch. So there's no place that exists where they intersect. And if the result is true, a true statement, then the system has infinitely many solutions. When did that occur?
If they're on the same line.
They are the same line. And how would you be able to tell, or what would you see in the problem? They would
It'd be an identity.
one of them would be in one form, and then they would give you the other equation, the same equation, but manipulated into a different form. Hoping you wouldn't be able to see. They would be checking to see if you saw that they're the same one or not.
I got negative 9, 3. Or negative 9, negative 3.
Oh, here?
Yeah.
So where did you plug in the negative 9? Into the
I
first?
plugged in, to the first one.
What is 2 times negative 9?
2 times negative 9 is negative 18.
Add 18 on both sides to get rid of it. What do you get on the right-hand side?
You get 24.
And what do you have left on the left-hand side?
4y, or negative 4y.
Okay, so now bring down here. Negative 4y equals 24. Divide by negative 4.
So y equals negative 6. Okay.
Got it?
Yeah.
All right, so they just told us that information. So what do you think is going to happen here? They're either going to give us one with no solutions or with infinitely many solutions. So you try this one. This one is solved for y. So because that one's solved for y, I'm probably going to use substitution here in this next equation.
We cannot.
Or the other way to do this is to get the equations into the same form. You get them in the same form, but you don't know on the test when this is happening. Right now, we knew this was going to happen. They were going to give us one of these trick ones.
You see the board.
On the actual test, you're not going to know when they give you the trick one. So you should probably not treat it as a trick one. You should treat it as just all the ones that we've been doing and solve it algebraically and come to your conclusion that way.
I'm stumped because
You're a tree. Stumped, get it?
yeah.
Sorry. Okay, line 3. You see that blank there? You know what I'm about to do.
What?
I'm removing the y,
Substitution.
and I'm putting in what y is equal to.
X plus 5.
And then you're going to distribute. Combine like terms, and you see something happens here. They get eliminated.
Infinite solution.
And it leaves you a true statement. So yes, infinitely many solutions.
Sort of got that.
It means no matter what you put in for x,
You're gonna get
it
at
will
the
always
same for y.
it will get eliminated no matter what. No matter if that's a million or in a million, then it's 2 million plus negative 2 million. Whatever it is, it's going to be opposite pairs, which are going to give you just 10 equals 10, which will always be true for whatever x you want to put in.
It also means that it's a direct variation, right? It goes through the origin.
No, look.
Well, I'm saying like, oh, where they intersect. Sorry. I'm saying like where they intersect.
So if there are infinitely many solutions, that must have meant that this line in blue is parallel to the red, or is it the same line as the red?
It's the same line.
Same line.
It's the same line as the red. That means if I solve this one for y, it will come out to y equals x plus 5. You could divide a 2 out of everything right now. You would get you would get y minus x equals 5. Then you would add x to both sides, and you'd have y equals x plus 5. It would be the same line.
So the y-intercept for the first, so the y-intercept would be 5.
5, and the slope
And
would
then
be
the slope
1.
would be 1 over 1.
It was just 1, yeah.
1.
Questions about this problem?
There's infinitely many solutions. Does that mean that the points can meet anywhere, or does that mean that the lines are parallel?
There are infinitely many locations in which the lines are making contact with one another.
Okay. When is it parallel and they never intersect?
Rosenthal.
Well, that when they're parallel and they don't intersect, then the solution, which means where they touch, because they never touch, and you're asking where do they touch, your answer is nowhere. There's no solution.
That's the no solution problem?
Yeah, it's when you have parallel lines. Now, parallel lines have the same slope but different y-intercepts, which they're probably going to show you on the next slide. Probably this one is that case.
Present.
Uh-huh.
Put the camera up, please.
Yes.
Thank you.
And I finally understand it now.
Good.
I got the next one.
Good.
Oh, did you print it out?
Yes, print it out. Since we're all home, we should all print it out. Much easier.
Oh, the lesson you printed out?
Yeah, it's much easier just to print out the lesson.
Thank you for sharing that. I do want people to hear that. I think that you're totally on to something there.
Oh, one's in standard form and one's in slope intercept form.
As long as one of them or both, as long as at least one of them solved for y or for x, it could be solved for x in the future, I'm going to go probably with substitution. So I'm going to take line 1. and copy it, except I'm not going to put anything for y. I'm going to put parentheses. Okay, and I'm going to substitute what y is here, because that y and that y are the same y at that location, and only at that location. I have to distribute. Copy down for line 4. So this will be negative 4x plus 8. And my prediction was wrong. 4x minus 4x is canceled. 8 equals 8. Infinitely
Many solutions.
I got it right. Yay.
solutions. I thought they were going to give us parallel lines. So these are the same line. All right. So if you divided everything by 2 here, you would get 2x plus y equals 8. You would subtract 2x on both sides, and you'd get y equals negative 2x plus 8. Oh, I didn't divide that by 2. That would have been 4. 2x plus 4, which is the same as the blue. All right. From the beginning of this problem up here, from the beginning, the left-hand side is the same as the left-hand side of the second equation. So if they're the same thing, they cannot come out to equal 2 different numbers. X minus y equals negative 4, and then x minus y is the same thing. It can only be in one location on a number line at a single time. It can't be negative 4 and 1 at the same time.
So they're parallel lines. Or are they impossible?
They must be parallel lines.
Mr. Rosenthal, can it be 2x?
So I would use elimination is what I would do. Okay? What I would do, now you can get this to be opposites by multiplying this line by negative 1. So that's negative, positive, negative. And then add. Then you get what? 0 plus 0 equals negative 5.
And that is not true at all.
False statement, no solutions. Okay? This is because when you graph this, this one would be y is equal to x plus 4. This one would be y is equal to x minus 1. One of the lines is doing this. That's y equals x plus 4. And the other line crossing here is doing that. That's y equals x minus 1. And they're parallel and they never touch. Okay? No solutions would be your answer.
Question?
No solutions. Yes, question.
Okay, so why do you add zeros? Oh, wait.
I added the equations. X and negative x make 0. Negative y and y make 0.
Okay, I understand what you mean. You're just sort of like canceling everything out.
I'm adding the equations like we did in those other problems. I'm using elimination. Hold your sounds, please.
So you just eliminate the x and
And the y.
and then you have negative 5.
Add negative 4 and negative 1, you get negative 5. And 0 does not equal negative 5. So when you do this algebraically with 2 parallel lines, you get a false statement.
I see how you could get that. Okay.
Mr. Rosenthal,
Mm-hmm.
on the test, instead of writing like no solutions or infinitely many solutions,
No, you cannot write NS and you cannot write
no, like,
IMS.
can we write symbols? The symbols like no solutions will be 0 and a cross over it. Yeah,
You can do that, yeah.
And for infinite, can we do infinite sign?
No.
Okay.
But you can do an empty set symbol.
Okay.
Well said.
Mr. Rosenthal, it's 11.
Okay, so we can finish this off and start our review when we finish tomorrow. We'll let the review take Thursday. Let's see, what is today? Wednesday?
Yes.
So we finish our review tomorrow, then we will go on to the test Friday. If not, we can always push the test back to Monday. If I push the test back to Monday, you should know statistically, just about every single time, the results are slightly worse if you take it on Monday than on a Friday.
I want to take it on Monday.
And then statistically, students almost always will ask, the majority, not every student, the majority always ask to push it back. So students statistically typically push for the worse outcome because they think that it's better for them. All right. So I'm just telling you that you might want to push it to Monday. You might think, oh, it's more study time. What ends up happening is you plan to study and you don't. You do something else. Okay?
Oh yeah.
And then you
get
forget.
distracted.
And then you lose the advantage of short-term memory. Now we want this to be in your long-term memory, of course.
Short-term memory.
I don't want to disregard the fact that you get a better test grade if your short-term memory is there helping you. Now you push it to Monday, you do lose some of this in your short-term memory.
But you have more study